All right, so organic chemistry is more towards focusing on organic compounds, right? Different types of organic compounds that you have learned so far in your syllabus, lah. Okay. So one of the things that we learn is that inside your organic chemistry, there are 5 different homologous series that you have come across. Okay. So what is homologous series? Homologous series refers to the members of the compounds of the members of the same family. So in your syllabus, we have only 6 different types of homologous series that we have learned, but only 5 which we will focus more towards. Okay, for the homologous series part, number 1, you have the alkanes. All right, and then you have the alkenes. And then, of course, you have the alcohol. You have the carboxylic acids. And lastly, you have the esters. And on a side note, of course, they also talk about alkyne, but very short lah. For the alkynes, they just want you to know how to name them and what is the functional group. So for alkyne over here, you have a carbon-carbon triple bond. All right, general formula of CnH2n minus 1. Minus 2. Plus pula, see? Okay, so that's the important part about alkynes lah. So the first member, of course, will be ethyne, for example. Okay, so for ethyne itself, you will see there's a triple bond. And then 1 hydrogen at one side. So that's pretty much it. So we'll focus more towards the alkanes, alkenes, alcohols, and carboxylic acids on esters. So again, let's just say what is the homologous series? Members of organic compounds that share similar characteristics. So the question now is, what are those general characteristics, right? So we can talk about the general characteristics. So we're gonna talk about characteristics. I'm gonna do everything in point form, easier for you to use it for revision. So characteristics of members of the same homologous series. Right. So what are the characteristics that we're looking at? So the first one, of course, will be that all these will share the same general formula. Okay. So I put here same general formula. All right. For example, alkanes will have a general formula of CnH2n plus 2. Right. Example name. No, no, write this down because we're gonna talk about one of this later on. So we got CnH2n plus 2, then CnH2n for alkenes. Then for alcohols, you have CnH2n plus 1 OH, and so on. Okay. So these are all just examples to show you that every single member of the same homologous series must be able to fulfill or to use this general formula to determine their chemical formula. Okay, so they must all have the same general formula. That's number one. Okay, and second one will be all members have the same chemical properties. It means that one alkane can burn, the rest can also burn. One alkane can undergo combustion, and the rest of the alkene can also undergo combustion. If the alcohol can undergo dehydration, then the other alcohols can also undergo dehydration. So they all have the same chemical properties, or they can carry out the same chemical reactions technically. Okay. Now, what about the others? Okay, now which brings us to the next point, a third point. Third point will be that if they have the same chemical properties, the question is why? Why do they have the same chemical properties? Because all of these molecules from the same homologous series, they have the same functional group. Okay, they have the same functional group. And also, the next one, each member of the homologous series will differ from each other by CH2. Which means as the chain length increases, then the chain will extend by just extra one CH2. So if you don't understand what I mean, for example, you see, let's just say we have ethane and propane. So you can see that the difference between ethane and also propane is that they differ each other by just an additional CH2. All right, you can add one more CH2 inside. And then if you have butane, you will see there's another extra CH2, that's it. All right, but the back and front always remains the same. All right, back and front remains the same. It's just that every time you increase by one carbon atom, you have also additional 2 more hydrogens. So that's why we say that each member differs with each other by CH2. All right. And then after that, we'll see, let's take a look at the differences between the different homologous series. So what do they differ then? All right, we say that all these members of the same homologous series have all these same things, same general formula, all right, same chemical properties, same functional group, then each member differs by CH2. But do they have anything that's different? For example, yeah, they have different physical properties, for sure. Because like you can see that every member has different number of atoms, right? when you have like ethane versus propane, there'll be extra CH2, means that they will have an extra additional carbon atom and hydrogen atom, right? And because of that, that will increase the density. When density increases, then of course the movement speed will be different. When the movement speed is different, also there's also other things like, for example, what's it called, the melting point and boiling point, right? Because we know that as the molecule becomes larger, then the van der Waals increases, and then more heat is required to separate them. So the intermolecular forces become stronger, more heat is required to separate them, then they increase in terms of their melting point and boiling point. But I will discuss more about that later on in specific examples lah. Okay, so everyone can understand so far? Any questions? No? Okay, so we're going to go on to the next one right now. So for the next part over here, we're going to talk about straight away, we're going to jump into the alkanes lah. Okay. So the first homologous series that we will talk about will be the alkane. So the alkanes are a group of saturated hydrocarbons. The word saturated hydrocarbon basically means that they have only carbon-carbon single bonds lah. Okay, I want to put a side note over here. Saturated means only contains carbon-carbon single bonds. Another side note over here, what are hydrocarbons? Because sometimes in the exam, they ask you to define what hydrocarbons is. So you put over here, hydrocarbons are compounds that contains only hydrogen and carbon. Okay, and then second thing about the alkanes will be that they have no apparent functional group besides the carbon-carbon single bond lah. All right, so we're going to talk about the general formula now. So for the alkanes, they have a general formula of CnH2n plus 2. Yeah, CnH2n plus 2. So they will all have to fulfill this same general formula. So the naming system is very easy. Okay, it starts with math. All right, naming. So for naming over here, I'll just show you lah. You have like the first few members: methane, ethane, propane, butane, and so on. So we have like an A and E behind as the naming system. Okay. All right. And then you must also understand that as they extend out, when they have a larger molecule, right? So as length of molecule increases, the van der Waals forces become stronger. So what does that mean? It means that as the molecule length increases, melting point and boiling point increases. More heat is needed to separate them. Okay. Also, first four members are gases. First four members are gases. Which refers to methane to butane. And then after that, the next 12 will be liquid. So I'll put a bracket here, C1 to C4. Next 12 are liquids. Which is C5. Hey, put a bracket. Aduh, sah. Yeah, you do the maths as well. Maths fail. So this will be C16. Okay, C5 and C16 will be liquids, and then others will be solids. Or put here after C16. After C16. Are all solids. What's the difference between molecular force and van der Waals? Van der Waals is a type of intermolecular force. Okay, van der Waals is a type of intermolecular force. So when we talk about intermolecular force, we're talking about forces that pulls the molecule close to each other. For example, you can see methane over here. All right. When methane comes close to another methane molecule, okay, for example, Then, for example, if this one comes close to each other, this part here will be your van der Waals. Okay. So we call this as an intermolecular force. And this one here is called intramolecular force, which is within the molecule. Intermolecular force means between molecules. Intra means within the molecule itself. So this one, of course, is called covalent bond. There is another type of intermolecular force called the hydrogen bonding, but it's only between hydrogen and fluorine, oxygen, and nitrogen. All right. So this is just to let you know what's going on between them. All right. So when we are breaking the bonds, we're breaking this one actually, this part over here. All right. We're not breaking anything else. We're breaking that one. This one very hard to break. So we're not breaking those. We are breaking the intermolecular force when we hit them up. Okay, so I think that's pretty much everything about alkanes in terms of its physical properties. If you want others, for example, the common ones, they are the same as any covalent compounds. For example, if you want to add another additional one, you can also add here. So things such as insoluble in water, but soluble in organic solvents. Okay, cannot conduct electricity. And if you want more, less dense than water. So those are the general properties of alkanes they need to remember. After this, we'll move on to chemical properties of alkanes. So for the chemical properties of alkanes, we'll discuss all of the chemical reactions they can carry out. So for the first chemical reaction we're going to discuss, of course, will be the simplest one, which is combustion. Okay, although we have only one, we have the first one is combustion. There are technically two types of combustion. Okay, combustion got complete combustion in excess oxygen. So for example, if you have methane, I'll use methane as an example, okay? CaH4 plus O2. You get CO2 plus 2H2O. Okay, so this is a complete combustion where your product will be carbon dioxide and water. And then say, for example, if you were to have incomplete combustion, which is in lack of O2, okay, then what you'll get is something like this. So you have methane as an example, so methane combusts in lack of oxygen. You will get carbon, either carbon or carbon monoxide. So I'm going to put carbon monoxide over here and water. Okay, carbon monoxide. So remember, I got either complete combustion or incomplete combustion. All right, and then for alkane, there's also something called cracking. Cracking is to technically break larger molecules of hydrocarbon into smaller molecules of hydrocarbon. So cracking will be very simple. So I give you the first example. Example 1. In this case here, if you have, say, for example, ethane that can be cracked to produce smaller fragments. In this case, I'll put here ethene plus hydrogen gas. Okay, so what I can do is that you can actually crack larger molecules of hydrocarbons into smaller molecules of hydrocarbons. But you must remember that you must yield one saturated hydrocarbon and one unsaturated hydrocarbon. Okay, in another example, let me show you. So the second example here will be decane, for example. So decane is C10H22. Now, regardless of how you want to break it, also can. You want to make it to smaller fragments, you want to split it half, it doesn't matter. So let's just say, for example, if we split it half, okay, C5 molecule, you realize that you can only get one pentane, which is C5H12, and you must have at least one pentene, which is C5H10. Whatever fragments that you decide to break it into, it doesn't matter, but you must remember to tally back the number of carbon atoms as well as the number of hydrogen atoms. So you must have 10 carbon atoms in the end after cracking, and you must have only 22 hydrogens after cracking, no more, no less. Okay, if not, then you'll be wrong already. Now, say for example, if you want to break it into something smaller, all right, say maybe your C10H22, you want to break it into even smaller particles, no problem. Okay, you want to break it into, say, for example, 1C2, okay, and then maybe 1C3, and then maybe the rest you can split into C5. All right. So you can see here, right? I have 3 different fragments. I have 1 carbon, 2 carbon atom, and 3 carbon atom. And then the last one is 5 carbon atom. All right. So total, I got 10 carbon atoms. Correct? Tally. What about my hydrogen? I got 4, 6, and 12. Correct. So it's 22. But what you notice is that I can only have 1 alkane at a given time after cracking, and I have 2 alkenes. So what I'm trying to say over here is that you need to have a combination of alkane and alkene. You can't have all alkanes into a smaller fragment. If not, then you realize that, oh, I have extra hydrogen atom on the right side, but I don't have enough on the left side. It doesn't tally anymore. Okay, same goes for above. Like you can see here, right? We have one alkane and we have one alkene. So no matter what happens, you must still have alkane and alkenes together. Okay, you can't have only alkanes on one side. Even the first one, also you see, right? You break it down and you produce one alkene and hydrogen gas, right? So that tells you that you need to have at least one alkene that's present, or more alkenes than alkane, to make sure that your number of carbon atoms and the number of what's it called, hydrogen atoms are correct. All right, and of course, one more reaction of alkane, which is technically the famous one, will be the substitution reaction. And this is quite famous because they always ask this in SPM. So this will be the third reaction, which is substitution. Now, for substitution, there must be a catalyst present. Is that you must have either sunlight or UV. Okay, this is the requirement that you must have, because it is called as a photochemical reaction. So I'll use methane to explain what's going on. Okay, so the mechanism is very simple. Imagine you have methane reacting with chlorine. Now, it doesn't have to be just chlorine. It can be bromine also, right? Gaseous halogen. So what happens is that the UV light will technically break the chemical bonds here. Okay, you'll break the chlorine-chlorine bond and produce free chlorine radicals. So after what happens is that the chlorine, one of the chlorine will substitute the position of the hydrogen, and the other one will combine with the other chlorine radical to form hydrogen chloride. So subsequently, what happens here is that I'm going to use a different color because it'll be very distracting for you. So I'm going to use maybe green color. Okay, so one of the chlorine attacks this one of the chlorine attacks this. Why is it like that? It's so weird. Never mind. And then this one attacks this one. Not attack like this combined. So chlorine substitutes hydrogen out, and subsequently you will have chloromethane plus hydrogen chloride. So in terms of balanced chemical equation, you can put here CH4 plus Cl2 with the help of UV. You'll get CH3Cl plus HCl. Right, that's the balanced chemical equation there. Now, if there are more chlorine molecules present and more sunlight or UV light, further substitution reaction can happen. So you will have the same molecule, which is the chloromethane earlier, reacting with more chlorine. and it will produce dichloromethane and hydrogen chloride again. So in terms of chemical equation, it will be CH3Cl plus Cl2, again with more UV. Then you will have CH2Cl2 plus HCl. And it will continue on doing the same thing over and over again until all of the hydrogen is substituted out. Right? And the final step will be the last one. So once the last hydrogen has been substituted out, then you will have your tetrachloromethane. Okay, sorry. Okay, so that's the last step already. This is tetrachloromethane. No more hydrogen left to technically display, so it's done. Sorry, testing on my pencil. So I drop it down and doesn't respond as well. But so what happened? Right. So if we were to replace the bromine instead of chlorine, it still works because it's a halogen. So as long as you have UV light present, you'll be able to carry out substitution. Now, alkanes usually do not have a lot of chemical reaction because it is a saturated hydrocarbon, right? It has only one, it has no double bond, so it's less reactive compared to the alkenes. So just to summarize a little bit. So technically speaking, alkanes will have only 3 reactions. So we have cracking, we have combustion, and we have substitution reaction. And then we'll do a bit more. So we have now the alkenes. So for the alkenes, they are called as unsaturated. Unsaturated hydrocarbon. So why is it unsaturated? Because it contains at least one carbon-carbon double bond. So secondly, it has a general formula of CnH2n, where you notice that the carbon to hydrogen ratio is 1:2. Right? So it has a functional group now. The functional group is technically the carbon-carbon double bond. Right. If you notice this one, right, for the alkanes, right, it's the same properties as the alkenes, right? One thing, all these are the same except for the states of matter and also the naming system. Okay. So what I'm trying to say over here is the first member, just remember this because it's quite tricky. Yeah. First member of the alkene family is ethene. There's no such thing as methene. All right, because they try to trick question. There's a trick question last time they asked that they said that draw the first name the first member of the alkene family, and then students tend to write methene. There's no such thing as methene. All right, because you need a carbon-carbon double bond, right? So you need two carbon atoms to have this double bond. So the first member will be technically ethene. That's how it looks like. Okay, now you're allowed to draw structures like this also. The orientation is not so important as long as you remember that each carbon atom has only 4 valence electrons, so it must have only up to 4 covalent bonds, not more than that. Okay. Right. So I think that's all I'll cover today, okay, because it's time already. So next week, come back, we will talk about the rest of the homologous series and try to finish out as soon as possible. Then we can try the questions together. All right. Questions? Do you have any before we leave? I realized I still owe you guys the videos. I already uploaded the video to YouTube already, but I haven't posted in Google Classroom. So I want to post it up lah. I already did it yesterday already, but I haven't posted to the Classroom yet. I'll do it afterwards. Can. I'll send you answers. All right. And then I'll send you the notes also, the notes just in case you miss any parts. All right. Nothing else. Then I'll see you guys next week. Thank you. Good night, everyone.